So hello students, welcome to the second part of our Leaky bucket program. So now we are going to we'll start our program. So let me open the gedit. So gedit will type the program name .c, right? So now once you open the editor, yes, so our editor is open. So let me increase the size. Okay, so now we know we should include some of the files like say stdio.h, then include stdlib.h, right? So now we are going to define one macro. So now we try to write a simple, either you can write a simple function to find the minimum of two numbers, or you can write a macro. So now we'll define a macro. So hash define minimum of two numbers x comma y. So we are going to check if x is less than y, you return x, else return y. This is a simple macro. So since we have used a macro and hash define we are writing, please take care that you are not supposed to end it with a semicolon. So this is a macro definition. So now we are going to start the program. So main. So now we want certain variables. Now we are going to declare some of the variables. So integer. Now what are the first variable? Output rate. So we should know what is the output rate of our leaky bucket. So we are going to take a variable called as output rate. Now we know drop. So now let us understand initially the number of packets which are going to be dropped. We will initialize it to 0. Now we need the capacity of our bucket. So we will take it as B size. That will be the size of our capacity of our bucket, how much packets it can store. So we need to find how many packets are remaining in the bucket. We'll take a variable rem and we will initialize it to 0 initially, right? Then we are going to take the time. So at each interval of time, how the frames or the packets are going to enter. So we will take a variable n second as our time. So now these are some of the important variables. Now we'll take some other variables, like say that we are to accept the packets. Like say when time is 1, how many packets are coming? When time is 0, at time 0, how many packets are coming? So we will take a single dimensional variable input. So now this is an input is a single dimensional variable. Let us say the size as 10. So and we initialize all these entries in this single dimensional array with 0. Now input 10 means what? So you can accept the 10 numbers of packets, that is n is equal to 10 also we can try to say. So in our example what we already discussed, we told that when time is 1, 600 packets are coming, when time is 2, 400 packets are coming. That is where we are going to take it in this particular single dimensional array input, right? We are initializing that initially to 0, and we'll take a variable I and we initialize this to 0 and a variable called as choice comma ch. That is, you want to keep on how many packets you want to accept. So these are the variables which is required for us in order to completely do this particular program. So now we'll start printf, right, /n. Now enter. So what we need initially, what you are going to accept, enter the bucket size and the output rate. So you are going to accept the output rate also. So scanf, so %d. Now what are the variables we have taken for bucket size? B si z e, and the another variable for output rate is out rate. So now two things we have accepted. So now we are going to use while loop or a do loop. You can keep on accepting this. So now no matter whatever loop you want, you can try to use. So let me take it as a while do loop. So do. So now what? So printf. Now we know, we have already seen the previous part A of our program, that now first we need to accept the packets, how the packets are incoming, that is incoming flow we have to define. So we will say printf enter the number of packets coming at second at what time? So percentage d, right? So now I plus 1. So now initially I is 0, then you are going to print I 0 plus 1 1. So at second one or at time 1, so how many packets now you are supposed to accept? So what is this, where we are going to accept all these packets? So scanf percentage d. Now we have taken a single dimensional array input. Now in this you are going to accept all the one by one the packets, right? So now one packet you accepted at time 1. So now the time has to be incremented, so we'll say I plus plus. So we are going to, since we are using do loop, so we are going to use this. So I plus plus. So now again second time will be 2 now. Since I plus plus you are telling, time will be 2. Now when time is 2, again you have to accept the packet, right? If you want, you can accept the packet, otherwise you can stop it there only. So for that purpose, now we are going to say printf slash n, enter 1 to continue or 0 to quit. So you can, whenever you want, you can quit, right? If you don't want, you can accept the second packet when time is equal to 1. So now you are going to perform all this in a while loop, so right? So do while this ch. Now you are going to accept this choice. So you want to accept whether 1 or 0, whether you want to continue or whether you want to quit. Quit means you are not quitting the program, you are stopping the acceptance of your packet, this incoming packet, whether you want to continuously accept the packets or you want to quit. Now if you are going to accept the packets continuously, how many number of packets you can accept? You are defined in array size only 10, right? That much you can accept. So we will accept the choice here. So scanf percentage d comma ampersand ch. Now you have accepted the choice whether to continue or not. So in this do while loop you are trying to do this. Now this is another part which has been completed. Now you see that everything has been ready with us, all the inputs have been ready. So you have got the bucket size, you have the output rate, we have defined the what is this variable for output rate. Now you have taken the incoming packets and you keep on doing it until you want to quit. So once you quit, so like say at time 1 or time 2 you are quitting, that means you have everything is, all the data is with us. So now we are going to start. Now initially we will put this, see, when you have accepted 2 packets, now I value will be 2. That is at time 1 you accepted one, time 1 you accepted some packet, at time is equal to 2. Here I you are incrementing, you have accepted another packet. Like this you are going to accept. Initially at what time you are going to stop? So the I value we store it in this seconds. That is the time, the maximum number of time how much packets have been received, right? So now we are going to printf. Now what is the format in which we want our output? So what we are going to print initially, we are going to print the time, right? Then received, how many packets have been received, so slash t. So next, how many packets you are going to send, this, then slash t will use to how many packets has been dropped, right? Then how many packets are remaining, so slash n. This is how we want our output to be displayed in a tabular fashion, one after the other. So now we will start the process. Now we will start our for loop. So while I equal to 0, now I is less than that last how many packets you have accepted, or, so this is an or operator, be careful what we are typing. I, if for I equal to 0 until the condition is I is less than totally how many incoming packets are there, or if there are any packets remaining. So we have declared initially it is 0, later on it keeps on packets you are going to keep on accepting in your bucket. So either your I is less than the last numbers how many incoming packets are there, or is there any packet left in our bucket. So we are saying until I less than n second, or until anything is remaining in your bucket I plus plus, right? Now you are going to use your for loop. So now what you want, so we will print the first values, right? Now observe here carefully. Now we are going to print the first values. Now what are the values you are going to print? As you have seen here, first time, then received, right? So now first printf %d. So time, what is the time? That is I value, so I plus 1. So you are going to print I plus 1 is the first value. So next received, how many packets have been received? So printf percentage. Now after leaving some space we will try to print, so that's why, so we will just leave let us say 5. After 5 spaces you are going to print how many packets have been received. So the packets what you are going to receive, it is stored in this variable single dimensional array input. So we will say input of I. So you print that. So now the third data which you are going to print is the sent, right? These are the things. So now we will say printf. Now observe here carefully. So I will give let us say some space. After 10 space we will print, because we want to display this value exactly below this sent here. So I will say percentage after 10 space 10d comma. Now we are going to use the function minimum. So already on top we have declared a minimum function, that is minimum of 2 numbers. Now you have to see that, so when you are going to send, now you know that, so by default what is your output rate? Output rate already you have defined here, like say in our previous example. Now our output rate was 200 packets. Now sometimes it may happen that it might be 200 or it might be less than 200, right? So for that we are going to say that minimum of, now in your input of I, right, input of I, how many packets are you are going to get? Like say sometimes you might be getting like say 100 packets, your output rate is 200 but packets are 100, right? You have to send everything. So input of I plus, now is there any remaining, is there already any remaining packets are there in the bucket? Either this or the output rate. So output, so out rate. Now in these two variable, now whichever is minimum, whichever value is minimum, that much you are going to send, right? So you are going to send that much. So in input how much packets you received plus if there is any remaining packets in your bucket, that value, and output rate, in these two. Now like say for example initially how much packets you have given in our example. First time when you are going to accept, now here you are going to accept 600, right? Now initially you accepted 600, so input of 0 will be having the value 600. So now 600 plus initially what is remaining, so we have initialized remaining as 0. So 600 plus 0, now you are going to get 600. What is your output rate? You have fixed it to 200. Between 600 and 200, which is minimum, 200 is minimum. So you are going to print the packets which you are going to send outside will be 200. Now this is what the explanation of this particular line, how we are going to do it. Now properly close the bracket. So we should close, we have 2 brackets here. Now this is the printf. Now 3 things have been completed. You have printed the time, how many packets are received, now how many packets are sent. Now these 2 things remaining, dropped and how many packets have been remaining, we have to calculate. Now how we are going to do this? Now we are going to use an if condition. We'll take a variable x. Now I think have you declared here? No. I'll go on the top. So we will declare another variable x, right? Now what we are doing? Now you take the input of I, that is the first how many packets you have received, you take that particular input plus, now is there any packets remaining in our bucket, right? Plus the remaining packet in our bucket minus output rate. Now what we are doing is, now we try to calculate these values. Like say for example at the first time input will be 600 packets, remaining is 0 and our output is 200 packets. So 600 minus 200, how much you get? 400, right? So 200 packets have gone, so remaining is 400. Now we will store this in x, right? Now this, after storing that value in x, now you are going to check whether this is greater than 0. Now we know that initially when you are going to start our process, we are going to get x is 400, which is greater than 0, Now after checking that if it is greater than 0, we'll use another if condition. If this x, that is 400 what we get, is it greater than our bucket size, B size? So because this is very important for us, right? Now we should know whatever the value you are having, now is it greater than the bucket size? Because now if this x value, if it is greater than the bucket size, there will be a drop in our packet. So that for that purpose we are using this. If x is greater than the bucket size, right? Now what we are going to do, now what will be your remaining? Now remaining will be the, how much will be the remaining? So if x is really greater than the size of our bucket, now in our example, bucket size was 500 and x was 400, x was less than this bucket size, so we'll go to the else part, right? Later we'll go to the else part. If x is greater than the bucket size, then the remaining will be your B size. Then the remaining number of packets will be B size, so there will be a drop. Now how much packets will be dropped from you? So drop will be equal to this x value minus now your B size. So many number of packets are going to drop. So in our example, in the second, when the time is equal to 2, again when you get 400 packets, now you have seen that there will be a drop of 100 packets. That condition will come here if you trace this particular program, right? So and this is what if x is greater than your bucket size. Else, now we'll come to the else part. Now if it is not greater than the bucket size, now what we are going to do it? That means if x is less than B size. Now if your x is less than the B size, at the initial stage, what was x? X here when we calculated, so it came 400, right? Now we come to the else part. Now since the x is 400 and it is less than bucket size, which is 500, so now what will be the remaining? So now we are going to calculate the remaining will be the x. Remaining will be x, and there is no drop in our packet, so drop becomes 0. So we are going to enter drop as 0, right? Now if it is greater than, x is greater than B size, we are going to do this. Now else we are going to do this. So now this is your end of our if condition, right? So here the end of this particular if, this if we are going to end here. So now if the x is greater than 0, we are going to do all these things. Now else what we are going to do? So else part. Now this else is for that this particular if. So when x value, if it is greater than 0, now we are going to do this. Now if x is less than 0, now we'll come to the else part, right? So now what will be? So the dropping bracket, so drop will be equal to 0 and remaining also will be equal to 0, right? Remaining packets also will be equal to 0. Now this is what we have done. So now you see this will be the end of your, now I can say if we have completed, this is the open if, for if open and close, or else open and close. Now this is for if, right? And else open and we have closed here. So now after this, so now we want to, now we have exactly calculated this drop and remaining. So till now we have printed these three things, right? Three things, three printf we have printed. Now we properly, based on our leaky bucket concept, now we have calculated what is the drop and how many packets are remaining. So now we are going to print those two values here. Now printf, right? So now we want to print the total number of packets which has been dropped. So percentage, now I want to print exactly below this dropped. Now we will use some 15 space percentage d comma. So now how much has been dropped, right? So instead of 15d, I will print both the values, then percentage and another 20 space I will leave. Now what are the things we are going to print? Drop and remaining, right? So now these are the two values which we are going to print. So now we are going to end. Now this is end of your for, right? Return 0, and this is the end of main. So let us save this program. lbuck.c. So we'll close the editor. So gcc will compile the program. So I am getting an error. So it is error is some return. So spelling mistake will be, I think it is there at the end of the program. So we'll open the program and let me check. Return 0 somewhere. Yes, return. So return 0. Yes, so we corrected that error. Now once again we'll run the program. So there is no error. So we'll run after compiling ./a.out. So now enter the bucket size and the output rate. So in our example, what we have discussed in the part 1 of our video, in that slide as well as in the classroom. So what was the bucket size we have taken? We have taken bucket size as 500. And what was the output rate? Output rate was 200. So now enter number of packets coming at time is equal to 1. So let us say we are going to get packet 600. Now it is asking enter 1 to continue or 0 to quit. Now let us just stop. We'll just say that we have received only this many 600 packets. Now I'll type 0 and I am going to stop here. So now we got the output, right? Now it is not coming in a proper style. So I think /n we have missed it. So we'll go to the program and we'll try to properly. So second line it is not displaying. So once you completed displaying all these 3 plus these 2, right here I want to display /n so that it comes properly in the next line. So I'll save the program, we'll go back, we'll compile the program once again. Now we will run the program. So out bucket size 500 and output rate is 200. Now let me give the first, you are going to accept 600. Well, now you see here what is the output you are going to get. So when time is 1, so when time, of course little bit alignment problem is there, so that you can once again go to your program and adjust with your /t or percentage some value, so that the printing, all the printing comes exactly in one particular line, right? So now you see here, first when time is 1, you received 600 packets, 600 packet is received, output rate is 200 packets, so the sent is 200. Now since there is no drop here, right, there won't be any drop, and remaining packet is 400. Now when time is 0, received is 0. So because already you are quit here also, we have quit, so you are not going to get any other packets. So now received will be 0. Now output sent is 200 packets. So remaining was 400. 400 minus 200, you will be now left with once again 200 packets. Again when the clock is incremented, third time also you are not receiving any packet. Output rate is 200. Since remaining was 200, you are sending 200. So there is 0 drop and remaining is 0. This is what we are going to get, right? Now we'll take the same input what we have discussed in our class as well as in the part 1 of our video. Now we'll try to give that input and we'll see that are we going to get the same output. I think here too much of space was coming, right? After send there is lot of space in, we'll remove one /t, we will try to remove. Okay, I will save this. So once again we'll compile the program and we are going to run. So now output rate is the packet size is 500, output rate is 200. Now incoming packet, first time I am going to take packet is 600. Enter 1 to continue. I will type 1, will go. When time is 2, we will take 400 packets, enter 1 to continue or 0 to quit. So we'll enter 0. So now we are going to see this calculation. Now you observe this calculation properly. Now this table, I think it is same as what we have discussed in the class. Initially 600 packet received, you sent 200 packet, there is no drop, and remaining was 400. Next, when clock is 2, now you see here, when clock is 2, that means after accepting 600 packets here, you entered 1. So you entered 1 to continue, 0 to quit. So you entered 1, and second time you accepted 400 packets, right? At second 2, you have accepted 400 packets. So when time is 2, accepted 400 packet, how much you are going to send? Output rate is 200 only. There is a drop of 100 packet. Why there is a drop? Already 400 was remaining with us, again you got 400, so total it became 600. Now out of 600, 200 you are sending, right? Sorry, 400 plus 400, how much? 800 packets. Now out of 800 packets, 200 packets anyhow you are going to send. So 800 minus 200, so 600 packets. But your rate, that is the bucket size is 500. You have given bucket size is 500. So you have 600. Obviously 100 packets should be dropped. After 100 packet is dropped, you are left with 500 packets. In the next time occurs, so you are not getting any packets, so you are going to send 200. Out of 500 you are transmitting 200 packets, so there is no drop, so the remaining will be 300 packets. Next time clock, again 0 packet you have received, and you are going to send 200 packets, remaining was 300. In that 200 you are going to send, so you will be having with 100 packets. Again when the time increases in the next time period, remaining was 100, you are going to send 100 complete packet, because maximum size is 200, but you have packet which is less than that, so you send all the packets, obviously no drop, and remaining is 0. So this is the entire program what we have implemented. Clear? So once again I'll open the program. Now you can just go through this program once again. Now what we have defined here: include stdio.h, include lib.h. Now here we are going to define a macro, that is to find the minimum of two numbers. You know that it is very simple, a small built-in program. You can write minimum of x comma y or a comma b, whatever variable you want you can take. Now if x is less than y, question mark x colon y, right? Don't put any semicolon at end of this macro statement. It is hash defined, so there should not be any semicolon here. So now int main, now you are going to consider output rate as one variable. How many packets are going to be dropped? Initially set to 0. The size of our bucket, b size, and remaining number of packets, initially we are going to initialize it to 0, and clock n seconds. Next, input. So the packets which you are going to get, if you are going to define in single dimensional array input of 10, and you initialize this to 0. This entire array is initialized to 0 first. Then taking a variable, counter variable I, initialize it to 0, ch for choice whether to accept or not the incoming packets, and we are taking a variable x. So first printf accept the bucket size and the output rate. So after accepting bucket size and output rate, now you are going to accept in this section, you are going to accept the packets, incoming packets. You are putting that in a while loop until you type 1 to continue or 0 to quit, that is ch value, you keep on accepting. What is that? You accept, enter number of packets incoming at this time, ampersand input of I. So once you have accepted all this packet, so next what we are doing, so you take your clock n second, initialize, put that value I into n second, that is totally how many packets you have accepted, right? That will be stored in n seconds. So and you are going to print this table: time, received, sent, dropped, and remaining. And we are going to calculate. We use a for loop for I equal to 0. I is less than total number of packets your incoming packets are accepted, or is there any remaining in your packets remaining in your bucket, any of this condition. Until that you keep on executing this for loop. So first we print only these three, that is the time is printed here, printf %d I plus 1, Next, received number of packets, because the incoming received packet is stored in this variable input of I, and how much packet you are going to send. How do you find how much packet you are going to send? Minimum of input of I plus remaining packets in the bucket and output rate. In these two, whichever is minimum, that is you are going to send, because you have seen that in the previous example, in some places at one particular place at the end you are going to have 100, output rate will be 200, but this will give you 100. Between 100 and 200, 100 will be the minimum, so that you are going to say that sent will be 100. There we are going to get this thing, right? After this, now you are using if loop, you are going to calculate this value x, how much is remaining temporarily, right? Now x is equal to incoming packet plus remaining packets in the bucket minus output rate, how much packet you are going to send. If this is greater than 0, then you are going to check if that value, if is it greater than bucket size. If it is greater than bucket size, there will be a drop, right? There will be a drop, obviously, since it is greater than the bucket size. Now how much will be the remaining? So the remaining will be your bucket size. Initially the remaining was 0, now whatever the size of the bucket, that much packets will be there, and remaining packets will be dropped. So how do you calculate that remaining dropped packet? So drop is equal to this x minus your bucket size will be the total number of packets which has been dropped. Now else, now your remaining will be how much? So whatever you have calculated, because x value will be the remaining, and there is no drop in the packet, so drop will become 0. Now this everything when x is greater than 0, else both drop is 0 and remaining also will be 0. It's very simple thing what we have implemented. So next, printf these two values, that is printf your drop and the remaining, right? So now this is your end of the program. So I think that in tomorrow's lab, so please try to look into this particular video, try to write clearly the program in your observation book, right, and try to execute this in your lab. So anyhow, so try to work it in your tomorrow's lab. Have a nice day. Now if you like this video, please try to subscribe to my channel, so that all the updating the next video sessions you will be receiving it. Try to subscribe to my channel and give the liking. Thank you very much. Have a nice day. Bye bye.